In this video, I'm going to review how you can find the kind of symmetry in graphs of functions. So there are two kinds of symmetry we're going to be looking at today. First one is line symmetry. In line symmetry, you're going to use a vertical line because remember, if it's a graph of a function, for it to be a function, it has to pass the vertical line test. So with line symmetry, you're going to have a vertical line that goes through the graph of the function, and each side is a reflection of the other. That means I can choose a point on each side of the line. It'll be the same distance away from the line of symmetry as it is on the other side. The second kind of symmetry is point symmetry. Point symmetry has the graph of a function that rotates 180 degrees around a point that matches the other side of the function. So below here I have three graphs. We are going to determine what kind of symmetry the graphs have. So the one on the left, this is a parabola shape. So if it's a parabola shape, parabola shapes do have line symmetry. We would normally call that the axis of symmetry because the axis of symmetry goes through the vertex of the parabola. So here I could easily draw a vertical line straight down through the vertex. And I can choose any point on the line on the graph. So if I choose this point here is 2 steps away from this line of symmetry. If I go 2 steps to the left of the line of symmetry, I'll have a point there. So they are mirror images. So the left-hand side over here is the same as the right-hand side if I were to reflect it over the line of symmetry. So this one is line symmetry. The second one, this one, we have 2 parts of this graph. I cannot draw a vertical line straight down through that because it wouldn't be a reflection over. So if I were to draw a line right here, and if I were to reflect this top one over the line of symmetry, they are not the same because the graph is down below. So we know this one is not line symmetry. This one would actually be point symmetry because if I put a point right here, and if I would rotate this graph 180 degrees, it would match up with this part of our graph. So we would say this has point symmetry, and the point that it would rotate around would be 0.20. Now going back to the previous one, I forgot to write down what the equation of the line of symmetry for this one would be. Since it crosses the x-axis at 1, we would say the axis or the line of symmetry would be x equaling a -1. Now our last example here, we have an oval here. So this one's a little bit unique. I could draw a vertical line test or do the vertical line. It does not pass the function. So this is not a function. But if I drew a vertical line, I do have mirror images on each side. So we could say that this is actually, this could have line symmetry, and it also is going to have point symmetry. So we would have a line of symmetry when x is equal to 0 because it crosses the x-axis at 0. We could also say if we wanted to make a horizontal line, we could say it crosses the y-axis at 0. But right now we're just going to use the vertical line. This is also, we could also say this is point symmetry because if I have the point at the origin and rotate this part around the origin, it's going to match up with this part. And this piece right here, if I go 180 degrees, it's going to match up with this piece. So we would have point symmetry around the point 0, 0. So we would say this last one could be line symmetry. We could also say there is point symmetry. So that is a quick review on symmetry in graphs of functions.